Hi, this is Mr. Ellinger. Sorry about no face on the screen. I know. I mean, it's not to increase the aesthetic quality of the video or anything, but I know it's just a little more interesting when there's a face. But unfortunately, my camera is having trouble again with not being able to save a video after I record both the webcam and the video. So sorry, you just get this. I've already done some of the problems because I recorded one video and then when it tried to save, it crashed, and so that's why we're just going to run through the problems I've already done, and then we'll keep going from there. This video is going over some selected problems that were requested from the multiple choice that was done over the last weekend. All right, here we go. Number five, I looked at it and I saw the n in the exponent, and you could see how I kind of rewrote it and thought, oh, this looks geometric-ish. And you can imagine, like if n is 1, n is 2, n is 3, it'd be e over pi, quantity squared, e over pi, quantity cubed. Definitely geometric, so it's the first term over 1 minus r. The tricky thing is that the first term is not 1. The first term is e over pi, because you have to say, oh, if I put 1 into this function here, what would be that first term? And the first term is not 1. If they had started at 0, then you would have, the first term is 1, but it starts at 1, so the first term is that. Had to simplify this to one of these, and did a little trick of multiplying the top and the bottom by pi. You could also get a common denominator and do flippy trick. Either way, you'd get the same thing. Question 2. This one, I saw it gave me h of x is equal to this, and what's h prime? I thought quotient rule. So I wrote down what the function was and then did quotient rule. Low d high, so that's second derivative of f, minus high d low over low. Plugged in the numbers. Everything is at 2 then, so I just plugged in, the corresponding numbers all at 2 and got this. Again, I haven't checked these answers yet. I just did them, and then at the end I was going to check the answers because maybe that my mistakes will be informative. But you probably know what the answers are if you've already done this test, so it wouldn't be that. I'm not hiding anything. How to find a Maclaurin series? There's a bunch of ways to find a Maclaurin series. You can use the formula, f of x equals f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial x squared plus ... The Taylor series formula centered at 0. But that's one way. But all those derivatives, those will be hard. I could do if it was geometric, if it looked geometric in form, like 1 over 1 minus x, I could use the geometric shortcut to find a Maclaurin series. This is not. So the other way is it could be something that's just memorized. Like if I asked you, what's the Maclaurin series for cosine x? That should be just a memorized factoid. Or you can take a memorized one and then tinker with it. And that's what I've done here. And so to find this, I said, well, what's cosine? Cosine is this. And so cosine of x squared means I plug x squareds in for all the x's. So I got what's inside the parentheses here. And then x times cosine of x squared, I just multiply everything through by x. And I saw that that matches up with the first one. Next one. Sorry, you can see I already did these. Evidence. In theory, you could do this with L'Hopital. You could say, oh, x goes to infinity. It's negative infinity in the top and then infinity in the bottom. So I could take the derivative of the top and the derivative of the bottom and work out that limit instead. Remember, you have to, if it was a free response, you have to show that it's an indeterminate form, 0 over 0 or infinity over infinity first before you use L'Hopital. But in multiple choice, who cares? That's not how I did it. I did it with the intuition stuff that I tried to build with you earlier in the year. Exponentials are bigger than polynomials. So this denominator is going to be much bigger than the numerator. So the answer is 0. That's how I did it. Next one, number 11. All right. So I looked at this one. I have to do an integral of this thing. And I looked through and I could see this looks kind of fundamental theorem-ish. I have to find the antiderivative of this and plug in 0 and plug in pi. So I kind of looked at it and I realized, oh, take a look. The derivative of the bottom is the top. So you could do it with a u substitution, but I really just said, okay, so I antiderivativize 1 over something, and then I know that that's my chain rule. So I did the antiderivative of 1 over this, which is just natural log of that. And then I can check this antiderivative by taking the derivative of this and seeing if it get my original function. So the derivative of this is 1 over this thing, there's the bottom, times the derivative of what's inside, which is the top. So yes, it's right. Plug in 0 and pi, get this. Second part is natural log of 1. And so therefore this goes away. It would have been easy to say natural log of e and accidentally say b on this one. So that's how I got that answer. Again, no idea if these are right or not. Okay, that was 11. 15. I got through a bunch here. So improper integral. So in theory, so I did this one a little more formally than I might have, but I just want to remind you that if it's an improper integral, going to infinity or going up to an asymptote, then you have to do the limit as the bound approaches that number. And so I did the limit as b approaches infinity of, and then I did the antiderivative. So I just said, okay, move the 6 in front. So I wrote the 6 in front. Oops, sorry about that. Wrote the 6 in front, and then antiderivativized this to the -3 halves, which would be that to the -1 half, pop the reciprocal in front, and then did a quick check of the derivative, and it worked. So from 1 to b, so I plug in b, plug in 1, and as b goes to infinity, this would go to 0, so you'd end up with -1 half inside times -12, which gives you the +6. So that's why I said C. And I think this might be the last one that I did before I ran out of time, because I'm going a lot faster this way because it's a little less organic. But yeah, this is the last one I did. But it's a little less organic, but it is quicker, having already done them and then just talking through them really fast. When you watch me do them in live and you do it live, then you get to see the mistakes or the uncertainties or something, which I think is helpful in moderation. So I looked at this. It's a differential equation. It's dy dx equals something with a y in it, especially over here. And then this looks like an initial condition. When x is 1, y is 1, I just have to solve this differential equation. So I did separation of variables. Remember, you can't get the y over here without just dividing by this whole thing. You have to multiply or divide. You can't add the y over. So I had to divide by this whole thing and then got multiply the dx up, and there's a 1 there. Did the antiderivative of both sides. Thought a little bit about first dividing by -1. I decided, nah, I'm just going to plug in 1, 1 now and figure out what c is. And so I plugged in when x is 1, y is 1, and solved it, got c. So now I can update it, and here I am. But now I have to solve for y because that's what it's asking me to. So I got to this. And then I thought, okay, y is 1. And so if y is 1, this is then the absolute value wouldn't do anything. It'd be the positive version of this because the absolute value, this is already positive. So I can drop the absolute value. So, and then add over, subtract over, and I got this. And for a moment, I was like, oh, shoot, this is the same as A, except mine is +1 and this one's -1. And that's where I ran out of time on the video. Whew, I did this 7 minutes faster. This is blazing. But while it started trying to save, I noticed that the correct answer is B. I saw it. It's like, oh yeah, it's just rewritten in a different way. But this totally matches up with B, so I'm fine with that. And so there you go. There's an organic Mr. Reynolds. You're figuring things out a little slowly because he's a little spacey right now. Next question I got was on number 22. What is the slope of the line tangent to that polar curve at that point? So we want dy dx, right? Which is dy d theta over dx d theta. And remember that y is just r sine theta. I'm showing you the derivation of this formula because I never remember it. I know there's the minus in the bottom, but it reviews a bunch of good polar stuff. X is r cosine theta. So now I'll find the formula. So it's going to be r prime sine theta plus r of cosine theta over r prime cosine theta minus r sine theta, just doing the product rule there. R prime is dr d theta. Dr d theta is just 3. So it's 3 at the point where theta is pi over 2. So sine pi over 2 is 1 plus cosine pi over 2 is 0. Don't need to worry about that. And then r prime cosine theta, that's 0. We just said that. Minus r, which is 3 theta. And so plugging in that, so that's 3 pi over 2 times sine theta, which is 1. So I'm getting 3 over negative 3 pi over 2. Cancel out the 3's and flippy trick up the 2, and I'm getting negative 2 over pi. Cool. I still got time. All right, 24, 25, 30. We'll see if I finish these in the first video. 24, 24, yep. Integral of f prime of that one, the piecewise, that's f, okay. So the value of this, I can just do fundamental theorem, right? So that's just f of x evaluated from 0 to 12. So that's f of 12 minus f of 0. There's no chain rule issue there or anything. F of 12 is negative 4 minus f of 0 is 4. I'm getting negative 8. Trying to think if there's any like great way to understand this. I'm not going to try to come up with one. I want to try to finish by 15 minutes. All right, number 25. Ooh, 25. Oh, this one. Yeah, I got this question over the weekend. Like some people who did this in the first, they did the multiple choice, and instead of doing the free response, they just went over the multiple choice, and we went over this one. So I saw this, and I immediately thought that I'm being asked that. I immediately thought of integration by parts right away because I got two functions, and they're multiplying, and so I'd rather take the derivative of x to get rid of it, and then I'll just have one function. So I'm going to make u equal to x. So du is 1 dx, and dv is f prime of x. So v is f of x. So the formula is that I'm doing uv, so that's x f of x, minus the integral of v du, which is just f of x dx. And the one thing that they were uncertain about, that I think a lot of other people forgot about also, is that this still has to be evaluated from 0 to 2 also. So it's going to be 2 f of 2 minus 0 f of 0. Okay, that's just going to be 0. And then minus this integral, which they already told me is 7. And 2 f of 2 is 2 times 5, so that's 10 minus 7. I'm getting 3. All right, and last one. And then we can check answers and see how we did on the answers. Maybe we'll have enough time. So f has a Maclaurin series, and the Maclaurin series converges to a function. So f of x is genuinely equal to 2 plus 3x plus x squared plus 1/3 x cubed plus ... Okay? Yep. G is e to the f of x. What is the coefficient of x squared in the Maclaurin series from G? What's hard about this one is I can't just do e to this and get an answer to that question. I really think the only way to do it, okay, I got it. Okay, so I'm going to think about the general formula. So the general formula for G, the Maclaurin series, it's going to be g of 0 plus g prime of 0x plus g double prime of 0 x squared over 2 factorial plus, and you'd keep going with the Taylor series. So the coefficient for x squared in the Maclaurin series for g is, I just need to know what g double prime of 0 is over 2 factorial is, and that's the answer to my question. So they gave me a lot of room. So g of x is e to the f of x. So g prime of x is e to the f of x times f prime of x, product rule, a chain rule. So g double prime of x is first times derivative of the second plus the second times the derivative of the first, which is just this thing again. And so g double prime of 0, trying to finish, is e to the f of 0, e to the f of 0 times f double prime of 0 plus f prime of 0 squared times e to the f of 0. And I don't think I'm going to make it and do a good job. So I'm going to stop the video here, and we'll start the next video with the end of this problem. So you can finish it if you want to and try to figure out what these f ofs are, but I'll do it in the next video.